Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear students, today we are going to study a topic called Einstein Relativity Principle. In this principle, Einstein sir has stated that mass of an object slightly increase when it moves with a velocity which is comparable with the velocity of light. That's my Einstein Relativity Principle. So let me write this thing. This principle states that this principle states that mass of an object mass of an object mass of an object slightly increase when it moves with a velocity when it moves with the velocity which is comparable or almost equal, which is almost equal to that of speed of light, to that of speed of light. So the equation for Einstein relativity principle is m is equal to the m naught divided by 1 minus v by c whole square root, where m is where m is the mass of the object moving with velocity v. The m naught is rest mass of the object, rest mass of the object. C is the velocity of light. C is the velocity of light, and we all know the velocity of light is 3 into 10 is to power 8 meters per second. So now let's discuss the various cases for this equation. So let's talk about the first of all case number 1. I am writing the case number 1. Under normal conditions or under ordinary conditions, under ordinary conditions we all know that we does not have anything in reality. Let me take an example of car or a motorcycle which can achieve the speed of light. That means that's we are talking about the ordinary conditions. That's why I have taken the example of car or a scooter or the motorcycle or a bike. Under ordinary conditions, the velocity of an object is very much less than the speed of light. Here I am writing V stands for velocity of object and C stands for velocity of light. Under ordinary conditions, we does not have anything which can achieve the speed of light, And in that case, I'm taking an example of car, bus, scooter, motorcycle. When we are walking or running, we can't even come close to the velocity of light. So velocity of an object is very much lesser than the velocity of light, which proves that v divided by c is very much less than 1. Or you can say, if we square it, v by c whole square, it will also become very much less than 1. So now let's substitute this value in the Einstein Relativity principle equation. It comes out to be m is equal to the m naught divided by 1 minus v by c whole square root. It comes out to be m is equal to the m naught divided by only 1, because v by c is very much less than 1. We are left with just 1, and the root of and the root of 1 is 1. So it's just m is equal to m naught divided by 1. So that means under ordinary condition, the mass of the moving object is equal to the mass of the object at rest. That is, I'm writing under ordinary conditions. Under ordinary conditions, the mass of moving object is equal to the mass of the object at rest. I just mark it clearly, at rest. So this was the case number 1. So now let's talk about the case number 2. Now I'm talking about case number 2. Let's take an example. If the velocity of any minute subatomic particle achieves the speed of light nearly to 3 into 10 to the power 7 meter per second. So let's take a minute particle and assume the velocity of particle that has achieved to the value of 3 into 10 to the power 7 meters per second. Now the speed of the light, we know that it is 3 into 10 to the power 8 meters per second. I have just taken an example in which the particle is moving with a velocity of 3 into 10 to the power 7 meter per second, which is almost equal to the speed of light, which is 3 into 10 to the power 8 meter per second. Now let's talk about the ratio of v divided by c. It comes out to be 3 into 10 to the power 7 divided by 3 into 10 to the power 8, which comes out to be 10 to the power minus 1. Now v by c whole square, it comes out to be 10 to the power minus 1 whole square. It comes out to be 10 to the power minus 2, or you can say it is 0.01. Now let's substitute this value in the main formula. I am having 1 minus v by c whole square root. Let's find this value first. It comes out to be 1 minus 0.01, because v by c whole square comes out to be 0.01, so I have substituted that. So it comes out to be 1 minus 0.01. It comes out to be 0.99 whole root, and this value comes out to be 0.994. Now let's substitute this value in Einstein relativity principle equation, and the equation is m is equal to the m naught divided by 1 minus v by c whole square root. So this thing comes out to be m is equal to the m naught divided by 0.994, and it comes out to be the mass of the particle moving with the speed comparable to that of light into 0.994 is equal to the rest mass of the particle. So that means when we multiply a bigger integer number with something, some value which is lesser than 1, that is 0 point something, its magnitude decrease, which proves that mass of the particle moving with the velocity approaching to that of speed of light slightly increase. This equation, this proves that, I'm writing, this relation proves that at the end, this relation proves that mass of the particle moving with velocity comparable to the velocity of light slightly increase. The mass of the particle moving with the velocity comparable to the velocity of light slightly increases. So now let's talk about case number 3. Okay, I'm now discussing now in case number 3. In case number 2, I have proved that the mass of the particle slightly increases when the velocity of that particle approaches to that of the speed of light. Now let's talk about the case number 3 now. This is case number 3, when the velocity of the particle is equal to the velocity of the light. Then what will happen? Now v divided by c, it will come out to be 1. Then v divided by c whole square will also come out to be 1. Now 1 minus v by c whole square root will come out to be 0, because v by c whole square is 1. Let me write one more step for you. It will become 1 minus 1 whole root, and you will get the 0. Now in Einstein relativity principle, it will become m is equal to the m naught divided by 1 minus v by c whole square root. It will come out to be m is equal to the m naught divided by 0, or you can say the ratio of m naught divided by m will come out to be 0. Now if the ratio of m naught, that is the mass of the particle at rest, divided by the mass of the particle moving with the velocity equal to that of light, it will become 0. For that thing, we have two cases. Let's talk about two conditions when m naught by m will come out to be 0. Let's talk about two conditions. The first condition, if the mass of the particle at rest is finite, it's a known value, and the mass of the particle moving with the velocity which is equal to the speed of light, it becomes infinite, only then you will get m naught by m to be 0. Let me prove this thing. The mass of the particle m naught, which is finite, divided by infinity, you will get an answer to be 0. Due to which what will happen? We know that the energy of the particle is equal to the mc square. If this m is infinite, then energy of that particle will also become infinite, which is very impractical thing. In reality, it will not be possible. So now let's talk about the another condition when you can get m naught by m to be 0. Uh, if the if the mass of the particle at rest is 0 and the mass of the particle moving with the velocity to that of which is equal to the that of speed of light, it becomes finite. If the mass of moving particle become finite and the rest mass becomes 0, then what will you get? It will be 0 divided by m, which comes out to be 0. So this thing is possible. Now let's consider that particle to be photon of light. Here I am considering that particle to be the photon of light. So the energy of the photon at rest, it will be m naught into c. Here I have taken m naught to be 0, so the energy of photon at rest comes out to be 0. So here I am writing rest mass of photon is 0. We got the rest mass of photon to be 0. That means energy of photon at rest will also comes to be 0. Will also come out to be 0. Come out to be 0. So we have assumed the rest mass of photon to be 0. Then the energy of the photon at rest will also come out to be 0, which is a very practical thing. And here we got proved our one point from the previous lectures, that let me write this thing with a different color because it's a proof. I'm writing, when photon in motion strikes an electron, it comes to rest after the collision. When photon comes to rest, its energy will be 0. That means that photon carries energy when it was in motion, which it has transferred to the electron, which has transferred all its energy to that of electron. So here I am writing, when the photon is in motion, first of all I am writing, when photon is in motion, it carries some energy. It carries some energy. Now the photon in motion strikes the electron, comma, after collision with electron, photon comes to rest position, and we have just proved that photon at rest carries 0 energy. All this proves that when photon strikes electron, it transfer all its energy, transfer all its energy to the electron. So this topic is a proof for emission and absorption spectra topic. Emission and absorption spectra topic we have done in the Bohr atomic model. You can see that previous lectures we have done emission and absorption spectra in the previous videos under the Bohr atomic model. So this point, this Einstein relativity principle proves that the photon transfer all its own energy to the electron. After that, photon comes to the rest. When the photon is at rest, it is having zero energy. That means it has transferred all its energy to that of electron. So now let's attempt one numerical on this topic. I'm writing a question for you. One numerical. The numerical is calculate the wavelength. Calculate the wavelength of electron moving with 1/3 velocity of light. So what will the students do? The mistake that will students 100% do. What will they do? They know the mass of electron is 9.1 into 10 to the power minus 31 kgs. The velocity of electron is given to be 1/3 of velocity of light, that is c. It comes out to be 1/3 into 3 into 10 raised to power 8 meters per second, and the velocity of electron comes out to be 10 raised to power 8 meter per second. What students will do, the mistakes that my all students are going to do, that will be they will use the formula lambda is equal to h upon mv. They will substitute all the values and they will evaluate this wavelength. But my dear students, here the velocity of electron is comparable to the velocity of light. So first of all, you have to evaluate the mass of electron. We have to firstly evaluate the mass of electron moving with the velocity of light, moving with the velocity comparable to that of light, moving with velocity comparable to that of light, by using Einstein relativity principle equation. That thing I'm also writing, by using Einstein relativity principle equation. So my dear students, carefully read your question and then decide which formula you have to use to evaluate the answer. Don't do any mistake. Carefully read the question. Here I have got the velocity of electron, that is 1/3 of the velocity of light, which is comparable to the velocity of light. That's why I will use the formula lambda is equal to h upon mv. But first of all, I will evaluate the mass of electron, which is moving with the speed of light, which is the speed which is comparable to the speed of light. I will not use the mass 9.1 into 10 to the minus 31 kg directly. I will firstly evaluate the mass of the moving electron. So let's use the Einstein relativity principle equation, which is equal to the m is equal to m naught divided by 1 minus v upon c whole square root. Now let's substitute the values. Here m naught is 9.1 into 10 to the power minus 31 divided by 1 minus, I got my v to be 10 raised to power 8 meter per second. So let's put it over here. It's 10 raised to power 8 divided by the speed of light is 3 into 10 raised to power 8 the whole square, and then whole root on denominator. This is the mass of electron which is moving with the velocity of 10 raised to power 8 meter per second. I got this thing to be m is equal to the m naught divided by 8 upon 9 whole root. After that it comes out to be 9.1 into 10 to the power minus 31 divided by 0.94. I have just evaluated this thing. Your final answer comes out to be 9.68. It is 9.68 into 10 to the power minus 31 kgs. Now just observe one thing. You have to observe that the mass of the electron moving with a velocity comparable to the light slightly increases. From 9.1 it has become 9.68 into 10 to the power minus 31 kgs. The mass of the electron increases by 0.67 into 10 to the minus 31 kgs. It is increased by this value. So the mass of electron has slightly increased when the velocity of electron has approached the velocity which is comparable to the velocity of light. So the mass of electron increased from 9.1 into 10 to the minus 31 kgs to 9.68 into 10 to the minus 31 kgs. It has increased slightly, and this is the topic that I have taught you, that you can come back to the very first definition which I have written, that the mass of an object slightly increase when it moves with a velocity which is almost equal to that of speed of light. So this thing has been proved in this numerical, that the mass has slightly increased from 9.1 into 10 to the minus 31 to the 9.68 into 10 to the minus 31. So now we got the mass. Now I am going to use the formula lambda is equal to h upon mv, the de Broglie equation formula. So the wavelength now comes out to be 6.626 into 10 raised to power minus 34 divided by the mass of electron came out to be 9.68 into 10 to the minus 31. It is the mass of moving electron into the velocity was 10 to the power 8 meter per second, and I got my final wavelength to be 6.8 into 10 raised to power minus 12 meters. So this is my answer. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please like, subscribe and share my channel to maximum number of students. Please do subscribe. Don't forget to press the subscribe button. Stay blessed.